Assalamu alaikum dear students. Today we are going to discuss about the intersection of two topologies. In this video you will learn intersection of two topologies and the example related to the intersection of two topologies. So let's move toward the theorem. If τ1 and τ2 are two topologies on X, then we have to show that τ1 intersection τ2 is also a topology on X. Here we have to show that the intersection of two topologies is also a topology. And this is a general case. Like whenever you will take two topologies, then their intersection will always a topology on X. Now let's move toward its proof. Let τ1 and τ2 are two topologies on X. We have to show that τ1 intersection τ2 is also a topology on X. Okay, so here we have to show the three axioms that we have taken in case of topological spaces. First we have to show that phi and x belongs to the topology τ1 intersection τ2. Then we have to show that if we take the union of the members, then their union will also belongs to τ1 intersection τ2. And third one is that we have to show that if whenever we will take intersection of two members, then they will also belong to τ1 intersection τ2. So let's move toward first axiom for this. Here phi and x belongs to τ1 and phi and x belongs to τ2. As we have taken τ1 and τ2 to be two topologies, as these both are topologies, so phi and x will always belongs to both of these, like phi and x belongs to τ1 and phi and x belongs to τ2. So as phi and x belongs to τ1 and phi and x belongs to τ2, it means that phi and x also belongs to τ1 intersection τ2. Because in case of intersection, we take the elements that are common in two sets. That is why as phi and x both are common in τ1 and τ2, then the intersection τ1 and τ2 intersection of τ1 and τ2 will also contain phi and x. So first axiom is satisfied because phi and x belongs to τ1 intersection τ2. Now move toward the second axiom. If we let that gi belongs to τ1 intersection τ2, now we have to show that the union of gi also belongs to τ1 intersection τ2. So here as gi belongs to τ1 and gi also belongs to τ2, means as intersection gi contains is containing intersection of τ1 and τ2, it means gi is contained in τ1 and gi is contained in τ2. So here gi belongs to τ1 and gi belongs to τ2. As gi belongs to τ1 and gi belongs to τ2, it means that gi is a set that is open set in τ1 and gi is also open set in τ2. As gi is contained in τ1, it means that the union of gi's will also belongs to τ1 because τ1 is a topology on X, and the union of gi will also belongs to τ2 because τ2 is also a topology on X. Okay, so as union of gi belongs to τ1 and union of gi also belongs to τ2, it means that union of gi belongs to τ1 intersection τ2 because intersection contain the elements that are common, and union of gi's is common both in τ1 and τ2. It means that union of gi belongs to τ1 intersection τ2. Okay, so second axiom is also satisfied that the union of the members also belongs to τ1 intersection τ2. Okay, now move toward the third axiom. Third axiom is that if we take the intersection of g1 and g2, and if this intersection belongs to τ1 intersection τ2, it means that g1 and g2 belongs to τ1 and g1 and g2 belongs to τ2 by using the property of intersection of elements and the intersection of sets. So if g1 and g2 belongs to τ1 and τ1 is a topology, it means that the members, if we take the intersection of members of τ1, it will also belongs to τ1, because tau1 is a topology. Similarly, in case of tau2, G1 intersection G2 will also belongs to tau2 because tau2 is a topology on X. So G1 intersection G2 belongs to tau1 and it also belongs to tau2 because G1 intersection G2 is both common in tau1 and tau2. It means that it will also be contained in tau1 intersection tau2, that is G1 intersection G2 will be contained in tau1 intersection tau2. So third axiom is also satisfied. And we have seen that all of the three axioms are satisfied. It means that tau1 intersection tau2 is also a topology on X. It means that whenever we take two topologies on X, then their intersection will also be a topology on X and it will always hold. It generally holds. Okay. So now move toward the example. We have taken the space X equals to ABC, space of three elements A, B, and C, and we have taken two topologies. Tau1 it contains X, Phi, and singleton A, and Tau2 it contains X, Phi, and singleton B. Both are topologies on X. Okay, and if we take the intersection of these two topologies, we will get X and Phi. As X and Phi both are common in tau1 and tau2, that is why we will get X and Phi. A and B both are not common, that is why we have not taken singleton A and singleton B. And we know that this is an indiscrete topology, and indiscrete topology is always a topology on X. So we have seen that we have taken the intersection of two topologies and we have got another topology. It means that intersection of two topology is also a topology on X. Okay, that means that whenever we take two topologies and we take the intersection, we will get the another topology. Okay, so that's all about our today's lecture. Good luck and Allah Hafiz.